हाय एवरीवन, गुड इवनिंग गुड इवनिंग गुड इवनिंग। आई होप मैं लाइव आ चुकी हूँ। एम आई ऑडिबल विजिबल? गुड इवनिंग एवरीवन, गुड इवनिंग, वेरी गुड इवनिंग टू ऑल ऑफ यू, ऑल माय NSEJS एस्पिरेंट्स। आई होप आप लोगों की जो तैयारी है NSEJS एग्जाम को क्रैक करने की, NSEJS 2025 बनने की, बढ़िया चल रही होगी। एंड जैसा आपको पता है, रिसेंटली अनाउंस हुआ है इंटरनेशनल फिजिक्स ओलंपियाड IPHO के लिए इंडियन टीम एंड हमारा एक स्टूडेंट रिद्धेश, जिसने अपनी जर्नी हमारे साथ NSEJS बैच में ही स्टार्ट की थी, राइट? ही इज पार्ट ऑफ इंडियन टीम हु विल बी रिप्रेजेंटिंग इंडिया इन IPHO 2025 इन फ्रांस। सो बिग 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 कॉन्ग्रेचुलेशंस टू रिद्धेश। एंड मैं इसकी एक बहुत इंटरेस्टिंग बात बताने वाली हूँ। रिद्धेश when he prepared for NSEJS exam, like he was there in the NSEJS batch, he worked really hard and indeed he has been very good student जो consistently effort कर रहा था for NSEJS and I was very hopeful कि वो बच्चा NSEJS qualifier बनेगा। बट जैसे आपको पता है, कई बार बहुत मेहनत करने पे भी, बिकॉज एग्जाम इज जस्ट अ मैटर ऑफ अ डे, कुछ मिस्टेक्स हो गई जिसकी वजह से ही couldn't be NSEJS क्वालिफायर। बट इसके बाद भी वो डीमोटिवेट नहीं हुआ। उसने जो NSEJS को लेकर अपनी प्रिपरेशन की थी उसका बेटर यूटिलाइज किया और नेक्स्ट ईयर से फिजिक्स ओलंपियाड के लिए लग गया। एंड फाइनली ही इज 11th मूविंग 12th स्टूडेंट एंड ही इज पार्ट ऑफ इंडियन टीम जो कि इंडिया को रिप्रेजेंट करेगा IPHO 2025 में, राइट? तो बेटा, इससे ये हमें मिलता है देखने को, सीखने को कि जब हम किसी टफ एग्जाम की तैयारी करते हैं या जब हमारे एम्स या मिशन हाई होते हैं तो हमें मोमेंटरली कोई झटका लग सकता है, कोई फेलियर का सामना करना पड़ सकता है, बट उसको हमें एज अ चैलेंज लेके आगे बढ़ना चाहिए। उससे डीमोटिवेट नहीं होना चाहिए, रादर उससे और हिम्मत लेनी चाहिए ताकि हम बड़ी अचीवमेंट को हासिल कर पाए, राइट? सो रिद्धेश की जर्नी से बच्चों यही आपके लिए बहुत बड़ी लेसन है, लर्निंग है दैट यू ऑल कैन टेक। ओके, यस, तो जल्दी से बता दीजिए। आई एम योर निधि मैम। आई होप यू ऑल आर डूइंग फाइन, एकदम बढ़िया, एकदम मस्त, एकदम ढिंचैक। एंड जैसा कि आप देख भी रहे हो, अगर आप B2A सीरीज को फॉलो कर रहे हो टू प्रिपेयर फॉर NSEJS 2025, सो प्लीज नोट कि ये जो B2A सीरीज है ये नेक्स्ट वीक ऑनवर्ड्स 13 मई से स्विच हो जाएगी, शिफ्ट हो जाएगी हमारे वेदांतु साइंस ओलंपियाड चैनल पर। तो प्लीज ये एक नया चैनल है हमारा वेदांतु का ही, फॉर स्पेसिफिकली साइंस लवर्स, साइंस ओलंपियाड प्रिपरेशन। तो अगर आप भी साइंस लवर हो, आप भी साइंस ओलंपियाड, चाहे जूनियर साइंस ओलंपियाड है या फिजिक्स, केमिस्ट्री, बायोलॉजी, एस्ट्रोनॉमी जैसा कोई ओलंपियाड प्रिपेयर करना चाहते हो, टारगेट है साइंस की, जेई की, नीट की सॉलिड फाउंडेशन तैयार करना चाहते हो, सो डू नॉट फॉरगेट टू सब्सक्राइब दिस चैनल, जहां पर हम एब्सोल्युटली फ्री बैच चला रहे हैं बच्चों फॉर NSEJS 2025 and JEE NEET Foundation आकार बैच, राइट? ओके, सो लेट्स मूव अहेड गाइज। आज का सेशन है हमारा मॉडर्न पीरियोडिक टेबल, अ ब्यूटीफुल अरेंजमेंट ऑफ एलिमेंट्स वेयर एलिमेंट्स आर अरेंज्ड according to their increasing atomic number, the arrangement given by Henry Moseley. So I am going to tell you the secrets, the details of this beautiful table. I'm sure if you are a science lover, you must be having this periodic table pasted in your room, on your room's door or in front of your study desk. So every science lover, this is a must have for every science lover. If you are a true blue science lover, then you should definitely have this beautiful periodic table right in front of you, right? So let us talk about this periodic table. As I told you, the history of arrangement of elements. So the periodic table was given by the modern periodic table that we use today was given by Henry Moseley, indeed a brilliant scientist. He was doing some, experiment of X-ray diffraction, where he got to know the fundamental property of an element. The behavior of an element depends upon its atomic number instead of atomic mass. Before Moseley, all the scientists who tried to arrange elements so that the study of these elements become easier, the arrangement was based on their arrangement. All the arrangements were based on atomic masses. But when Henry Moseley concluded that atomic number is the important fundamental property of an element. So the element should be arranged according to their atomic numbers, right, by doing this X-ray diffraction experiment. And he gave this relation also, Henry Moseley. The frequency of the rays diffracted, that is directly proportional to atomic number. This is the relation given by Henry Moseley. The graph, you can see the atomic number versus the frequency of the diffracted rays. So A and B are some constant, depends upon the element. So he arranged according to atomic numbers. So when he arranged elements according to their increasing atomic number, he observed the chemical and physical properties of elements repeat after certain interval. That means the physical and chemical properties of elements are the periodic function of their increasing atomic numbers. Right? Yes. Got it? So guys, he arranged element and gave this beautiful table. I just showed you in the last session also. Hi Ashwini and Soumya Shorts, this session is live, right? So this is the modern periodic table, the arrangement of element according to the increasing atomic number given by Henry Moseley. This is the periodic table, right? So let's decode this periodic table. So in this periodic table, we have vertical columns, right? And they are known as groups. So in this periodic table, we have 18 groups. You can see the 18 vertical columns, they are known as groups. And we have horizontal, right? Horizontal, lines of elements, they are known as periods. So in modern periodic table, this is the modern periodic table given by Henry Moseley. We have 18 groups and 7 periods, right? And also you can see in this periodic table, we have 4 blocks. This is S block, first and second group. We have the P block here from group number 13 till group number 18, and in between we have D block, right? This is D block. And below we have F block. F block has 2 series. One is lanthanide, the above series is lanthanide, and the another one is actinide, right? So if I talk about the periodic table, this modern periodic table, so we have 18 groups, 7 periods and 4 blocks, S, P, D and F, right? As I told you, if you can see here, after 57 atomic number, we have directly 72 atomic number. That means after 57 atomic number, we have 14 elements placed below, known as lanthanides. After lanthanum, lanthanum itself is a part of D block, but after lanthanum, we have 14 elements placed at the bottom, right? Similarly, after actinium, we have 14 elements placed below in the second series, known as actinoids, right? So we have in this periodic table 18 groups, 7 period and 4 blocks, S, P, D and F. Now let me tell you what we call the different elements. So Ashwani, this is for class 9th and 10th, specifically for students who are targeting Junior Science Olympiad NSEJS exam. Okay guys, so you can see here, so these are actinium and the 14 elements post actinium are placed here, right? So please keep in mind, this is a biggest misconception with many students. Lanthanum is a part of D block. 14 elements after lanthanum, they are lanthanides and they are part of F block. Similarly, actinium itself is a part of D block. Whereas the 14 elements after actinium, they are placed in F block actinide series, right? Yes. Now, let me tell you small little terms. So the group 1 elements, lithium, sodium, potassium, rubidium, cesium, they are known as alkali metals. Alkali means water soluble base, right? So the elements of group 1, they form water soluble bases, sodium hydroxide, potassium hydroxide. So they are known as alkali metals. So group 1 elements are known as alkali metals. Whereas group 2 elements, beryllium, magnesium, calcium, strontium, barium, radium, they are known as alkaline earth metals, because again they are alkaline in nature and their oxides and hydroxides are found in the earth crust, right? Yes. Alkali metals, group 1 element, alkaline earth metal, group 2 elements. Now, the last group, 18th group. This is noble gases. They all are gases, inert gases, noble gases. They don't react. They are very stable gases. Yes, very stable gases. Helium, neon, argon, krypton, xenon, radon. They are noble gases, inert gases. All these gases, they do not react. They are very stable. Right? Non-reactive. They are having peace in their life. Very stable. Right? So, in the nirvana state, you can say helium, neon, argon, krypton, xenon, radon. Got it, guys? Now, let's come to group 17. Fluorine, chlorine, bromine, iodine, astatine. They are known as halogens. Why they are known as halogens? Halogens means salt forming. So, fluorine, chlorine, bromine are the members of halogen group. They are salt forming. Sodium chloride, potassium bromide. So, these basically elements of group 17, they form salt. Right? Yes. Now, group 16 element, oxygen, sulfur, selenium, tellurium, polonium, they are known as chalcogens. Why they are known as chalcogens? Chalcogens means ore forming, right? So, basically, ores are the substances from which metals are extracted profitably. So, if you see ores of many metals, they are generally oxides, sulfides, ore, right? So, oxygen, sulfur belong to group number 16, oxygen family. So, they are known as chalcogens. Now, come to group number 15. Group number 15 is nitrogen family, nitrogen ka parivar, nitrogen, phosphorus, arsenic, antimony, bismuth. So, group 15 is known as nitcogens. Nitcogens means throat choking. Arsenic is the member of group 15, AS. This is indeed a poisonous element. It will choke your throat when you have it in excess or, inhale it much, right? So, nitcogens, that means group 15 elements, they are known as nitcogens, right? Now, representative elements. What are representative elements? So, the elements of S block, that means group 1 and 2, and the elements of P block, except noble gases, group 18, they are known as representative elements because they represent their class. So, in S block, I have metals. While I move from S towards P block, I have non-metallic character, non-metals. So basically, S and P block represent their categories, metals and non-metals. Got it? Yes. So S block and P block elements, they are known as representative elements except group 18 elements because they are noble inert gases. Right? Now, let's talk about transition elements. So here we have in S block metals, in P blocks we have non-metals, and there is a change from metallic behavior towards non-metallic behavior through these D block elements. These 10 groups belong to D block, right? So these D block elements are known as transition elements. Transition means change, right? Yes. So we are moving from metals towards non-metals. So there is a change in the behavioral properties of elements via this D block. So they are known as transition elements. And I already told you, few elements are taken out from D block and they are placed below in F block. Right? So we have taken these F block series, 2 series, lanthanides and actinides. From here only transition elements, so we call them inner transition elements. This F block elements, lanthanide and actinides, they are known as inner transition elements. Right? Also known as rare earth metals because they are rarely found in earth. Most of them are radioactive. Most of them are like they are man-made, right? Rare earth metal, heavy metal, F block elements. They have different properties. We use them in nuclear reactors for nuclear reactions. They are synthetic elements, many of them. So we place them below separately in the periodic table. Right? Yes. So we have S, P, D, F block, 4 blocks, 18 groups, 7 periods, right? And we have different name, representative elements, alkaline alkaline earth metals, halogens, chalcogens, nitcogens, inert gases depending upon their behavior. Can you please tell me what are coinage metals? Which form coin? Right? Which form coin? Copper, silver, gold. The elements of group 11, copper, silver, gold. They are metals which were used to make coins. So they are coinage metals. Platinum, gold and silver, they are known as noble metals because they don't react. That is why we make them in the jewelry. Very good, Rudra Singh. Copper, gold and silver, they are coinage metals, right? Yes. Okay, now so these are the elements you can see: lanthanoids, 2 series in F block, actinoids, rare earth metal, noble gases, halogens, and all of these, right guys? So if I talk about the modern periodic table, this arrangement, I've already told you 18 groups, 7 period. The shortest period is, which period is the shortest period? Which period is the shortest period here, guys? The first period just have 2 elements, right? The shortest period has 2 elements, right? Short period has 8 elements, long period has 18 elements, and the longest periods, they have 32 elements in the periodic table, right? Okay. So guys, 4 blocks: S block group 1 and 2, P block group 13 to 18, D block group 3 to 12, and F block, the series placed at the bottom, lanthanide and actinides. This is indeed a beautiful arrangement of elements, and yes, ho gaya hai organism, right? Like it is, of course, indeed it is there. OG is there, no? Rudra, OG is there, right? So we have OG, gas organism is there. So guys, this is indeed a beautiful arrangement done by Moseley, Henry Moseley. I told you the tragic story of Henry Moseley. He died at just a young age of 27 in World War, right? So before, like in the previous times when World Wars were there, like many person from the different profession, they participated in the wars, right? So similarly, when the World War broke, so Henry Moseley also went on the war, though he was a scientist, he was a physicist and very renowned physicist, right? And he represented, he was fighting for his country. But in that World War, he got killed, right? So post his death, it was a shock to the whole world because he was doing a lot of stuff in the field of physics, in the field of science, and losing the person, that means that was a big jolt, big break to the science. So then onwards, it was declared that no scientist, no renowned personality will participate or will represent or fight for his country in any of the war. Because losing Henry Moseley in a world war means losing a lot of science. Because if he was alive, he could have done a lot of work in the field of science. Till the age of 27, he had already contributed a lot. And to honor his contribution, the year he died, nobody received the Nobel Prize in Physics because everybody believed if Henry Moseley was alive, he was the best suitable contender to win Nobel Prize in Physics. So to honor his achievement, to honor his journey, Nobel Prize in Physics was not given in that year, right? So losing Henry Moseley in a world war where he was fighting for his country, that was a big loss to the whole world, not just his country, to the whole world, right? Yes. So Henry Moseley, a physicist, just try to understand how resourceful he was, how intelligent he was, that being a physicist, he arranged the elements. He gave the periodic table that we are using till today, right? So this is the modern periodic table, guys. I've already told you about the basics of modern periodic table, the halogens, the noble gases, zero group and everything, right? Yes. Okay. Now the demerits. Their modern periodic table is really good. We are still using the modern periodic table. Yes. Okay. So now There are certain, of course, few demerits in the modern periodic table, like hydrogen. Hydrogen is a controversial element. Hydrogen shows property like group 1 also. Hydrogen shows property group 17 elements also, like, right? So it shows behavior like alkali metals, also like halogens. So what should be the position of hydrogen? Should we place it with alkali metals or should we place it with halogens? The position of hydrogen is still controversial, guys, right? Second demerit, why these lanthanides and actinides, they are placed below at the bottom of the periodic table, while we took them out of the D block transition element and we placed them below? That is again a question mark, right? Helium has configuration 1s2. It has electron in s subshell, but still we place helium in p block because it is a noble gas. So these are few demerits in the modern periodic table also, but indeed the merits are more. That is why still using this best arrangement till date, right? Now, what was the use of, what was the use of, if I ask you what is the use of periodic table, why the scientists were looking at the periodic table? Why the scientists is looking at the periodic table? Why they were looking for the arrangement? So that the study of elements can become more systematic and easy, right? Yes. So now how can we see the arrangement so that we can get an idea about the properties of elements? Okay, Rudra, silicon is a metalloid. We generally place it as a metalloid. It has properties like metal also and non-metal also. Dr. Ashok, my favorite IPL team. See, my favorite IPL team, I can't comment, but I can comment my favorite player in the IPL. Of course, Vaibhav Suryavanshi, the one of your age. Aapki umr ka bachcha, right? He is doing like great in his field because of his hard work and dedication. Fastest century, world recording performance, right? So world record performance by a 14-year-old child, I can say, right? Of your age only. He's breaking the records. He's playing among best top players of the world. Still, he is able to, make that record. Vaibhav Suryavanshi, I hope you have heard about the, child, right? So you should all take inspiration from him. Nothing is impossible if you want to do, right? With his hard work, passion, and because he come out of comfort zone, he could achieve what he desired for. So take an inspiration, not just the field of sports or IPL or cricket. It's everywhere. If you have certain goals in your life now, give your heart and soul to it. Definitely you will achieve those goals. It is just that you are supposed to come out of your comfort zone, right? You all have a lot of potential in you. Just try to realize that potential. Just work on yourself and you can achieve whatever you target, right? So take the inspiration, right? Okay, guys. So let's get back to our periodic table from IPL. So guys, the elements of the same group, they have similarity in properties. If I talk about lithium, sodium, potassium, rubidium, and cesium and francium, they all have similar properties. They show similar kind of reaction. What is the reason? Why the elements of the same group, they show similar properties? Yes, why they show similar property, guys? Anyone? Can anyone tell me? Because they have similar outermost electronic configuration. Lithium, the configuration is 1s2 2s1. The sodium outermost configuration is 3s1. Potassium 4s1. So their outermost shell has similar kind of electronic configuration because the outermost electrons are the electrons which participate in a chemical reaction. Same subshell, same electron. So similar kind of behavior. So because of the similarity in the valence electronic configuration, the elements of the same group show similar properties, right? This is the reason for their periodicity in properties, right? So you should know why they show similar properties. Now, another thing, if I ask you, I give you some atomic number and I ask you what is its position in the periodic table. For example, I say, so you have an element without looking at the periodic table with atomic number 11. What is its position? Position means you have to tell its block, its group and its period. So how can you tell the period, block and group of an element in the periodic table? By knowing its atomic number. Okay. So first thing what you are supposed to do is write the electronic configuration. So 1s2, 2s2, 2p6, 3s1. This is the electronic configuration of atomic number 11. Now, the last electron, the subshell in which the last electron enters, that is the block. That means the last electron enters the S subshell. So the block of this element is S block. This element belongs to S block of the periodic table, right? Now, the maximum value of principal quantum number or the valence shell, the outermost shell, the maximum value of shell, that is the group. So that is the period of the element, right? So that means this element belongs to third period because 3 is the outermost shell. So the period of this element is 3. Got it? And now let's get back to group. Now group depends upon block, right? So if it is the S block element, the number of valence shell is equal to group number. So for S block element, let me write here, for S block element, valence electron, number of valence electron is equal to group number, right? For P block element, if element belongs to P block, group number, group is equal to 10 plus number of valence electron, right? Yes. And how can we tell D, the group of D block element? I will tell you just now, right? So how many valence electron it has? 1. So that means the group number is 1, right? Yes. Got it, guys? So let me take another example. Suppose you have atomic number 31 and you are supposed to tell the position of this element in the periodic table. First write the configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1. Got it? This is the configuration. So the last electron enters the P subshell. That means the block of this element belongs to P block. This element belongs to P block. Now, period of this element, the maximum value of shell. Fourth shell is the valence shell. So this belongs to fourth period of the periodic table. Got it? Yes. Now, group. Okay. Now it is a which element? P block element. So for P block element, group number is 10 plus valence electron. How many valence electron it has, guys? How many valence electron it has? So ma'am, fourth shell is the valence shell. Do not forget this also. This is also fourth shell. So in fourth shell, we have total 3 electrons. 2 here, 1 here. So we have total 3 electrons in the fourth shell, which is the valence shell for this element. So ma'am, group will be 10 plus number of valence electrons. That is 13 valence electrons we have. Got it, guys? Yo? Yes? Done, 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 done? So, block, period and group. This should be very clear to you. Now, let's move on to the next. For example, I have element with group number, say 28, right? Now let's write the configuration first. First thing is to write the configuration. 1s2, 2s2, 2p6, 3s2. Everyone should know how to write the configuration. If you don't know how to write the configuration this way as PDF, please go and watch my session of the same series, how to write the electronic configuration from structure of atom, atomic structure. In the same series, you will get a session how to write the electronic configuration, guys, right? So just check the playlist, guys. 3d8, total 28 electron. Now the last electron enters the D subshell. So the block of this element is D block. Now the period of this element, the maximum value of principal quantum number, the valence shell is the fourth shell, outermost shell, right? Yes. Now group. Now it is a D block element. Now please listen carefully how to tell the group. of a D block element, right? So if it is a D block element, so last electron must enter the D subshell. Okay. And before that D, there was S subshell which was filled, right? So the total number of electron in that lastly filled D and before that the S, the total number of electrons in these two subshell, the D which was filled at the last and before that second last S. So total number of electron 2 plus 8, that is the group, right? So the group of a D block element, the number of valence electron in S subshell of the valence shell, 4 shell is the valence shell, and D subshell of the second last shell, right? So that is the group number of a D block element. So by knowing the just atomic number, you can tell which block, which group, which period this element belongs to. So you should know how to tell the position. Position means group, period and block of an element from the atomic number, right? I hope this is easy, and if someone gives you the atomic number, you can tell the position, right guys? Now another important thing on which many exams asked questions before, that is diagonal relationship. So in periodic table, if you look at periodic table, so you can see lithium has magnesium diagonally to it in the periodic table. Beryllium has aluminium diagonally to it. Boron has silicon diagonally to it, right? So these three pairs, lithium, magnesium, just these three pairs guys, only these three, which are lying diagonally to each other, lithium, magnesium, beryllium with aluminium and boron with silicon, they show diagonal relationship. That means lithium has similar property to that of magnesium, beryllium has similar property to that of aluminium, the properties of boron and silicon are similar. They are lying diagonally to each other in the periodic table, only these three pairs. So lithium has similar property to that of magnesium, beryllium has similar property to that of aluminium, right? Boron has similar property to that of silicon. This is known as diagonal relationship. Questions were asked, you should know what is diagonal relationship. Which element, which pair show diagonal relationship? Now why their properties are same? Why lithium has similar property to that of magnesium, ma'am? Yes, reason because the size of their ions, lithium ion and magnesium ion, almost same. Their polarizing power is almost same. What is polarizing power? We'll study in chemical bonding, right? The size of their ions, their polarizing power, they're almost same. That is why they are showing almost similar kind of behavior. So lithium with magnesium, beryllium with aluminium, boron with silicon. Indeed an easy peasy topic. If you know, you can mark the answer correctly, but many times questions have been asked on this topic in many exams. Diagonal relationship. Got it guys? Yes. So which elements have diagonal relationship? Lithium with magnesium, beryllium with aluminium, boron with silicon. Okay. Let's move ahead. So I have already told you the periodic table, the modern periodic table given by Henry Moseley, and similar kind of periodic table was given by a group of chemists, right? Of Bohr, Bury, they all give another periodic table which is known as long form periodic table, long form of periodic table, which is exactly the same as modern periodic table. But they said we make our table, we make our arrangement on the basis of electronic configuration. Everyone knows that atomic number and electronic configuration, they are like synonyms to each other, right? So atomic number 1, 1s1, atomic number 2, 1s2. So of course the arrangement will be similar, right? Just to save their, grace, because of physicists came and gave the arrangement of elements, that was kind of, very disrespecting to chemists. So that might be a reason that all the chemists, they just clubbed together and gave exactly the same replica. They just said we arranged the element on the basis of electronic configuration, right? Yes, not exactly Rudra Singh, that is not exactly. Polarizing power is something else, but you can say it is similar to that of electronegativity, what is there in electronegativity, right? So screening or shielding effect. So please can you tell me What is your seat in your class, in your school? Are you a front bencher or a back bencher? Where do you sit in your class? Front bench or back bencher? So if you are a front bencher, that means you are shielding the back benches from the teacher. Suppose teacher is the nucleus and you all are electrons. The students are electrons. The students, those students who sit on the front benches, the hold on those students, teachers hold on those students is more, because teacher can look at their notebooks and what they are doing, right? Whereas the back benchers, they are being screened or shielded by the front benches. So the hold of teacher is weak on those students, because teacher cannot see what they are doing, what they are writing in their notebooks. That means the back benches got shielded by front benches from the teacher. Same happened in the atom. So nucleus is the teacher, electrons are the students. So the electrons, which are the inner electrons, they shield the outer electron from the force of nucleus. So you know, nucleus has a positive charge, electron has a negative charge. Yes? Yes? So there is a force of attraction. So basically, there is a decrease in force of attraction of nucleus and the valence electron because of the inner electrons. So basically, I can see, yes, so the inner electrons are shielding the outer electron, right? Yes. So this is shielding or screening effect. The decrease in force of attraction between nucleus and the valence electron because of the shielding, screening by inner electrons. Yes, that is known as shielding or the screening effect. So you can read the definition here. This decrease in the force of attraction between the nucleus and the valence electron is due to the presence of inner shell of electron, right? So basically, as you just say, tomorrow is like war drill, mock drill for war tomorrow. So let me take an example from the army only, right? So basically, the army is shielding the borders, right? The army people are shielding the borders. So more is the person in the army, more is the number of soldiers in the battalion, better they can shield the border. So more is the inner electrons, better they can shield the valence electron. Yes? Got it? And more strong the army person is, more strong the soldier is, more fight it can give to enemy, and better shielder the soldier is. Yes? Got it? So same. Inner electrons, basically they are shielding the outermost electron from the nucleus, right? More is the number of inner electrons, better is the shielding. Less attraction from the nucleus, less hold from the nucleus that valence electron will feel. Got it? Yes. So the shielding, more is the inner electron, more is the shielding effect. Shape of the orbital, as I told you, if the army is strong, the soldiers are strong, they can shield in a better way. So we have S, P, D and F, right? So S orbital electron, that is Golu-Molu, spherical shape. So the Golu-Molu, if the front benches, they are quite healthy or tall, they can shield the back benches more effectively, right? But if the front benches are very lean and short in height, will they be able to shield the back benches properly from the teacher? Of course not. The healthier, the taller front bencher is, the better shielding he will give to the back bencher, right? Same. So S orbital, the shape of S orbital is spherical, Goal-Matol. So the electrons of the S orbital, they are the better shielders. They are very strong. They shield very nicely, right? Whereas the electrons of the P, they are relatively poor shielders. But D and F, because they are so diffused in shapes, they don't do better shielding. If a student keeps on hopping or keeps on changing its seat in the class, how he can shield the others? He keep on changing. He's not localized. He's not at one place properly, right? So you should all know the order of shielding. The best shielders are S orbital electrons, and then P, then D and F. D are poor shielders. They cannot shield the valence electron properly from the nucleus. And F, they are good for nothing. They are the poorest shielders. Got it, guys? Yes. So S, P, D and F depending upon their shapes. Got it, guys? So this is the shielding effect. So basically what happens is nucleus is attracting the electron because of opposite charges. Electron, they are repelling each other. So overall the total force experienced by the valence electron, the attractive force of nucleus is less, right? So effective nuclear charge experienced by the electron is written as Z effective. Effective nuclear charge, that is Z minus some constant which is known as screening constant. Sigma is screening constant. The sigma value is the shielding constant, the screening constant, which can be calculated using certain rules which are known as Slater's rule, right? So basically Z is the atomic number, because atomic number is the number of protons in the nucleus, the strength of the nucleus, right? It has to, be less. Got it, guys? The sigma is the screening constant or the shielding constant. Got it? Yes. So screening effect, shielding effect is the decrease in force of attraction between the nucleus and the valence electron because of the shielding or screening by inner electron. Now this shielding effect indeed is important because in further lectures we are going to learn about the various periodic properties. So in all those properties we are going to use the shielding and screening effect. Yes. Got it, guys? Okay. So Santosh Jain, how can I study for JEE chemistry and physics from this channel? So if you want to study from JEE and physics, we have another channel, Vedantu Science Olympiad, where we are running a free batch daily 8 to 9 p.m. We are coming live on that channel, right? That is known as Vedantu Science Olympiad channel. So there is a ACAR batch, which is for JEE and NEET Foundation. You can follow that series, right? So that will help you for Olympiad preparation also, JEE and NEET also, right? So guys, okay. So shielding effect, in the next lecture, we are going to study the periodic properties. Make sure that you all know. And next week onwards, this series, B2A series, which we are running in English for NSEJS 2025 aspirants, we are shifting this series to our new Science Olympiad channel, Vedantu Science Olympiad channel. Do not forget to subscribe. Let's have a quick rapid fire. Let's see how many facts you know. Yes, which period is the longest period of the modern periodic table? Can you tell? Which period is the longest, having maximum elements? Yes, of course, Santosh, that will be sufficient for Olympiad preparation and also for your JEE and NEET Foundation. Yes, Rudra, P and D, P is dumbbell and D is double dumbbell. Which period? There are not 18 periods, there are just 7 period stages in the periodic table, what you are saying. So 6 period, just look at your periodic table. 6 period has maximum number of electrons. Next, which metal has the lowest density in the periodic table? The element, the metal with the lowest density in the modern periodic table. Let's see if you know that. Which metal has the lowest density? Yes, please. Let's see if you know that. Of course, lithium. Lithium is having the lowest density among metals, right? Next, which metal has the highest melting point? I told you in the last session, if you watch that session of the same series. Highest melting point we use in our homes also. It is indeed tungsten that we use in our bulb filaments, right? So tungsten, the symbol is W. It has the maximum highest melting point. That is why we use in the filaments, right? Yes. Okay, the next one, let's have the most poisonous element. Of course, you all should know by now, plutonium. Plutonium is the most dangerous, deadly element. Okay, Which is the most abundant element in the earth crust? Most abundant, most found element in the earth crust. Element, oxygen. Oxygen is the, I'm not asking metal, I'm asking element, Rudra. Okay. Which is the most abundant inert gas in atmosphere? Most abundant. So inert gases are group 18 elements. Helium, neon, argon, xenon, krypton, radon. So out of them, which is the most abundant gas? No. Earth. I'm not asking in universe. Earth, I'm asking, not universe. Argon. Your air has argon, right? Argon. The element in the periodic table which has lowest density. The element, not the metal. The element out of all the elements in the periodic table, the one with the lowest density. The one with the lowest density. Hydrogen, right? Hydrogen is the element with the lowest density, the lightest, you can say. The metal which is bad conductor of heat and electricity. Generally, metal are good conductors, right? The metal which is bad conductor of heat and electricity. Quickly let me know. Lead. Lead is a bad conductor of heat and electricity. Lead. Metal. The non-metal having highest melting point, that is carbon. Carbon is a non-metal with the highest melting point, the diamond, right? You can see the diamond. So carbon is the non-metal with highest melting point. Yes, which is the most abundant metal in earth crust? Now please answer. Most abundant metal. No, lead is generally considered as poor conductor as compared to the other metals, gold, silver and all, because it has high resistivity, Rudra. Lead is a poor conductor basically. And another reason is that your lead, it readily reacts with oxygen to form lead oxide, which doesn't conduct electricity. Now it is good. Aluminium, yes. Aluminium is the most abundant element. The element in periodic table having highest density, not the metal, the element. Osmium. Osmium has highest oxidation state, highest charge also. The element of the periodic table which are in liquid state in and around room temperature. Elements liquid at room temperature. Bromine, mercury, cesium, gallium, rubidium and francium, basically not rubidium. Bromine, mercury, gallium, cesium and francium. Rubidium needs a lot of a bit more temperature. So bromine is liquid, mercury is liquid, cesium, gallium, they are, and francium liquid at room temperature. The element in modern periodic table which are present in gaseous state. Noble gases and hydrogen is exist as a gas, nitrogen, oxygen, fluorine, chlorine and all noble gases. They are gases, right? They all exist in gaseous state. These elements exist in gaseous state. Which element sublimes on heating? Please suggest an element which sublimes, which becomes, which vaporizes on heating. Can you know that element? Do you know that element? That is having violet or purple color. Iodine, which is solid, which sublimes on heating. Iodine, the purple color, the violet color, right? Okay, hemoglobin is a complex compound. Which metal is present in hemoglobin? That is in our blood. What is present in hemoglobin, guys? Hemoglobin has which element? Which metal? It has iron. This is the structure of hemoglobin. You can see here, right? Chlorophyll. Which element is present in chlorophyll? Chlorophyll has, of course, magnesium. This is the structure of chlorophyll. You can see here. They are complex compound, right? Name the metal which is the best conductor of heat and electricity. Of course, you know silver. Silver, best conductor of heat and electricity. Name a non-metal. Non-metal which is the best conductor of heat and electricity. Can you name a non-metal which is the best conductor of heat and electricity? Non-metal. Yes, quickly let me know the non-metal best conductor of heat and electricity. Graphite, which is of course allotrope of carbon, which is carbon only. Graphite, right? Well done, guys. So let's have questions from today's session. Quickly let me know the answer. Which of the following do not show diagonal relationship? Which doesn't show diagonal relationship? Lithium, magnesium, beryllium, aluminium, boron, silicon, carbon and sulfur. Out of these four options, which pair doesn't show diagonal relationship? Indeed, carbon and sulfur is not the part of diagonal relationship. Well done, guys. Next, which element doesn't belong to P block? P block is from group 13 till group 18. Which element, arsenic, gallium, strontium and polonium, is not part of P block of the periodic table? Strontium. Please see where the strontium is. Beryllium, magnesium, calcium, strontium, barium, radium. Strontium is a part of which block? Arsenic, gallium, polonium, they all are a part of P block. SR. Strontium is a part of S block. Now, which is not a chalcogen? Sulfur, selenium, oxygen and sodium. Chalcogen, which is not a chalcogens. Chalcogens are group 16 elements, which is not a chalcogen. Group 16 element, which is not part of group 16. Of course, sodium, it is an alkali metal, group 1 element. Oxygen, sulfur, selenium, tellurium, polonium, they are group 16 element chalcogens. So D, donkey, that is sodium. Na is sodium. It is alkali metal, group 1 element. Right? Yes. So guys, that's all for today. Make sure that you remember element group wise. So you should know, you should learn S and P block group wise and transition elements and F block period wise. So this is how you are going to use them for questions also, right? So take a note, guys. Do not forget to subscribe our new channel Vedantu Science Olympiad for your Science Olympiad preparation. This channel, we are going to shift this series on that channel. Bye. Take care. God bless you all. Keep learning, keep growing, guys. Let's bring gold for India, right? पढ़ते रहो, बढ़ते रहो, मचाते रहो, देश को गोल्ड जिताते रहो.